All righty, want to do a quick video here on the homework assignment. I don't want to take a lot of time with it, so let's get to it right away. All right, and I'll just tip the desk a little bit left and right so that we can keep right on moving. All right, so first thing you were given was, I guess, 4 functions, and you're asked to graph each. So let's have at it. Exponential growth on top of -5. First jump is 10, next jump is 30, and that happens with a change of 8. So we got 1, we change by 8, we got 9. 10 minus 5 is +5, minus 5 and 30 is 25, and that has been accomplished. All right, I know we're going to look at when does f of x equal 2. Not much space here, so we'll find a height of 2, which is over here, a little bit later. All right, so we'll take care of those questions a little later. We'll estimate, and then I'll erase. All right, e to the minus x exponential decay on top of a constant of 4. First jump is 20. Next jump is 60. We're creating that 3-to-1 nice ratio. That occurs when x is 0. 20 plus 4, yep, 24. And then 60 plus 4 is 64. When negative x equals 1.1, so negative 1.1 approximately gets me 64. There's our graph. I guess we were talking about domain and range. So the domain on this, I'm going for x's. My x's are headed to -infinity and +infinity. So no restriction. No restriction. All x is possible. Y's, however, I don't see anything that isn't bigger than -5. Okay, domain and range for this exponential function, same consideration. No restriction on the domain. Y's greater than 4, okay, for the same reasons. When we do the logarithms, we're going to have restrictions on the domain and no restriction on the range because they're inverses. All right, so we're on the logs. All right, so vertical asymptote for exponential. Horizontal asymptote for exponential, vertical for the log. So we've got x equals 4. We're going to put in a 5. Then we're going to put in, we want 1/3, 5 1/3. Okay, I think I'm going to be coming down this direction because it's the inverse positive with something less than 1. So it's going to be in that vicinity. So let's make this a 5. Let's make this 5 1/3 is probably higher. So let's put 5 1/3 up here. Okay, cut to the chase here. So 5 minus 4 is 1. That disappears. You get a 6. Remember, log of 1, regardless of the base, although bases have to be positive, regardless of that positive base, getting a 0, and 0 times any kind of multiplier plus a constant is going to get you the constant. All right, so we know that 5 gets us a 6, and 5 1/3 probably going to get us 8, but let's check it out. 5 1/3 gets us log base of the base, which is always going to be 1, and 1 times m plus c is going to be m plus c every single time. All right, so 2 plus 6 is 8, and that is now complete. Domain and range, restricted. Oh, 5 didn't put the 8 there. Restricted domain, x's have to be greater than 4, and no restriction on the range. We're going down to -infinity for y values. We're going up to +infinity for y values. So all reals. Why don't I write that? Why? All reals for range. Okay, we'll get that out of the picture. All right. Same thing here. However, I have a positive and I have a 2.71 roughly base. So that's going to be the inverse of growth, which is going to look like that. X equals 7. We're going to pick an 8. 8 is going to get us 4. And then we're going to pick 10, because 10 minus 7 is 3. We know the value of the ln of 3. So 2.2 plus 4 is 6.2. and that came with a what, a 10. Okay, domain. X's have to be bigger than 7. And the range, all reals. Okay, and if you're looking at a inverse relationship, over here you had a 3-to-1 vertical ratio of change, and here you have a 3-to-1 horizontal ratio of change. Okay, so now what do we have? Well, if we've been able to, I hope I had everything. Yes, looks like you could barely see everything on the screen. So if we can take an equation and draw the graph, then we should be able to go from the drawn graph back to the equation. So what do we have? We have a y value, and the other y values are bigger, so they're above it. We're going to go from -1 to 10 on the x's, and our y's got bigger, so we have exponential growth. We have y equals 2 as an asymptote. 2 to 7 is a jump of 5, and 2 to 16 is a jump of 14. So what do we have? We have y equals 2 plus 5. Next time it's not 5, it's 14. And then we've got x values of, where are we? -1. So x plus 1 divided by, that takes 11 units of change to enact this exponential growth. X equals -3. Okay, so we can graph it. 5, 3, 5 to 11, my x's are getting bigger, my y's are getting bigger, so it's definitely that shape. How do I get from -3 to 3? That's 6 units. So let's see, how do I want to do this? Let's just start with the y's. I think it's quicker and easier to start with the y's. So y equals 3. So I actually said something very stupid there a moment ago. Y equals 3 plus 7. And we know it's a log. So that takes care of your y values, because we're going to make this a 0 and a 1. A 0 gets rid of that, giving me a 3. A 1 makes 7 plus 3, giving me that. Domain restriction, -3. So x plus 3 must be stated. And dropping in a 5, 5 plus 3 is 8. So we'll make that divided by 8, which gives us log 1. Remember what we said a moment ago, log 1 is 0. And 0 times anything is going to get me +3 here. 0 times 7 plus 3 is going to get me 3. So I have just made a 5, get me a 3. 11 plus 3 is 14 eighths. 14 eighths, I guess we can reduce it 7/4. We'll keep it as 14 eighths, though. Might be better to see it that way. I'm not sure. So we'll drop in 11. 11 plus 3, 14/8. Okay, what do you put on top? 14/8 to get 14/8, 1. So 7 plus 3, 10. We're done. All right, so that takes care of that. Domain, no restriction. Where am I? I'm in the logs, I'm sorry. Domain, where's the equation? Up here. I did an exponential. I am rushing, aren't I? Exponential. Domain, no restriction. So I was right there. Range, however, y's are greater than 2. For the log, domain, restricted. X is greater than -3. No restriction on the range, so -∞ to +∞. All right, ln of 24. Yep, you can see. ln of 24 could have done a better job. Rules of exponents are much easier to get your answers here quickly. Showing why the rules work is still essential, I think. So 8 times 3 is 24. 2 to the 3 times 3. 2 is e to the 0.7 times 3 times e to the 1.1. So we've got 3 times 0.7. We've got 3 times 0.7 plus 1.1. That's the exponential activity associated with this calculation in E notation. Well, 3 times 0.7 is 3 ln of 2 plus 1.1 is the ln of 3. So that must be a rule coming out of this. So how do we see it? How do we see it? Well, 24 is 8 times 3. We said multiplication is addition. Ln of 8 plus ln of 3. Ln of 8 can be written as 2 to the 3 plus ln of 3 over here. And we said you can put the 3 in front. There's your 3 ln of 2 plus ln of 3. And then you take those decimal approximations and you get a quick answer, 2.1, 1.1, 2.1, 1.1, I guess 3.2 is the approximation. So 2.71 to the 3.2 is going to get us very close to 24, slightly larger than 24 because these are ln of 2 is 0.69 with a, I don't remember the decimals after it. And the first two decimal places for ln of 3 are 1.09, and then more repetition after that. Decimals. It's got repetition, just like pi, going on forever. All right, so that takes care of that. Now I got to see where we are on the rest of the sheet. So I'll do a quick eraser job here. Yeah. Let's get rid of this section of the board. Maybe I can just work here, depending upon the level of difficulty of the questions. That gives us enough space. Just trying to get ourselves some work in before the final exam. So let me get my glasses, which I put where? Right over here, so I can read what's on the sheet. And it should be some perfunctory mechanics at this stage. All right, we should be able to craft a statement regarding ln of 6 minus ln of 2. All right, division is the ln of 6 divided by 2. We know that this is equal to the ln of 3, right? Because the rule. All right, so what is 6? 6 is e to the 0.7 times e to the 1.1, and I'm dividing by e to the 0.7. We can see the cancellation. We get e to the 1.1. So what is the ln of e to the 1.1? Yeah, it's 1.1. What do you put on top of e to get e to the 1.1? 1.1. All right, so division implies subtraction, and ln of 6 could have been written as the ln of 2 plus the ln of 3 multiplication, right? 2 times 3 minus ln of 2. That's another way to see the ln 2's canceling out of the problem. Ln of 3, 1.1, approximately. All right. I don't know if I crafted a sentence here or not, but we talked about the process. So you can use these rules to solve equations. Minus log base 2 of 3 equals 4. So we now know that log base 2 of x over 3 can be stated, and that's equal to 4. So therefore, x over 3 is equal to 2 to the 4. So x is equal to what? 2 to the 4, 16 times 3, 48. Okay, so that's our answer. And 48 divided by 3 is 16. And what do you put on top of a 2 to get a 16? 4. All right, so that takes care of that. Log 1 over 1,000. Log 1 over 1,000. Well, it's not stated. It's certainly not stated, but it's a base 10. That's a common log. We don't write it. So if it's not written and it's not ln, then it's base 10. All right, and so 10 to the what gets us 1,000, negative 3, right? Because we really have 10 to the third in the denominator. So that's the exponent you put on top of the 10 to get that calculation. All right. Log. I saw the m's. Log m squared over of m to the 2, m to the 6 to the 7th. So we're looking for m squared to what exponent gives us m to the minus 4 to the 7th, gives us m to the minus 28. I guess x is negative 14. Done. 243 to the negative 2/5. 243 to the negative 2/5. All right, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, I believe. Let me check again. Yep. All right, so what is the 5th root of 243? It's obviously 3. All right, so 243 to the negative 2/5 is the same thing as 1 over the 5th root of 243 squared. Okay, I got the reciprocation, I got the 5th root, and I've got the squaring, and so that's 1/9. Simplify. Simplify log 32, 1 over 4. Same base, that's 2 to the 5x equals 2 to the negative 2, so x equals minus 2/5. And fifth root, again, same calculation as the last one, actually. $10, write a function that has $10. So here's a function, takes $10, cuts it in half. Every 2 years, starting, I'll use t, and what time? 2020. Okay, all right, that's how you write that. And then we want to be able to change to E notation. The world works, business, banking, industry, science, works in E notation. So how do I convert 5 to the 1/3 to the x over 10? Well, we know what 1/3 is. It's e to the negative 1.1 roughly, x over 10. So that's 5e to the negative 1.1 x divided by 10. I hope we know how to move decimal places. E to the negative 0.11 x is roughly the same as what we started as. Okay, continuing on. I'll upload this. You're going to look at it for homework tonight. If the interest rate is 4% and you invest $100, when will you have $200? So $200 equals 100 at 4%, e to the 0.04t. That's what we're solving. So we know we want to get 200, so that's a doubling exponent on top of e that we need. And we also know it's at 4%. So that's 0.7, roughly 0.7 divided by 0.04, which is the same as 70 divided by 4, which I always call 15, and it's wrong. It's 17.5 years, okay? And you should not leave it this way. That does not give the reader a sense of how many years. This does, okay? So a more discerning look at your answer keys, you would have seen that a month ago. All right, sketch e to the x. There you go. 0 gets you 1. E to the 0 is 1. E to the 0.7 is roughly 2. E to the 1.1 is roughly 3. Goes to positive infinity for the y's. Goes to 0 on the other side because we have 1/2, 1/3. We could do a fourth. We could do a fifth. We could do this forever. 1 over 1,000. Right? We can continue doing that forever. All right, so that's e to the x. ln of x is the inverse of these table values. The inverse of these table values are the 1/3, the 1/2. So let's start from here. Yeah, I guess that'll work. X equals 0. So if that's a half, then that's 1. If that's 1, that's 2. If that's 2, that's 3. Okay, and we've got 1, negative 1.1, negative 0.7, 0, 0.7, 1.1, just the inverse. Going up to positive infinity for the y's, slowly going to negative infinity for the y's, quickly. Okay, good enough. Domain and range. Domain, x greater than 0. Domain, x equals all reals. Range, y equals greater than 0 for e to the x. That's e to the x. Y's all reals. All right, so I said we'd get through that quickly. I hope we did. I hope it's no more than a 20-minute video. Gonna find out right now because I'm gonna cut the kibosh on it. There we go. End.